So with all the new GPUs being released, especially the 40 series, I'm realizing that my GPU test bench is actually quite a big bottleneck, and it's time to build another one. And we're going to be using a very interesting case, this one over there.
Looking for a cheap way to license your Windows? Check out WhoKeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out WhoKeys in the video description below.
So for the motherboard, we're using the ROG Strix Z790A gaming Wi-Fi. This is a DDR4 motherboard. The DDR4 is cheap, and it's probably the best DDR4 motherboard you can get for 12th and 13th gen. Now I know that there's Z790, I think MSI's got one Z790 as well with DDR4, but this is very good motherboard for what we're going to be using this for. For CPU, we're going to go with no other than the 12900K. I just pulled it out from a PC setup that has been probably sat there for about a year, ever since we did the Johns Plus i100 Pro build. So do you remember the mini SFX build? That build's been actually sat there for quite a long time, so I finally managed to pull it apart, and then we can use the i9 from there. Previously, we were using the B660 motherboard and an i7 12700, which actually is quite a bit of a pain just because it can't boost all the time to the maximum wattage there, and we're using or losing quite a lot of performance. This one here has also very fast Wi-Fi built in, which is very good because then I don't have to connect it directly to my NAS here, but I can actually transfer all the files that I'm creating here, often like the screen recordings and things like that, through the Wi-Fi. Boom, across, don't need any wires, nothing. Very simple, little easy, and gets the Wi-Fi very fast as well. The current one, I had to use a little Wi-Fi dongle in the B660 Creator Wi-Fi motherboard because it doesn't actually have Wi-Fi built in, which is a bit of a nightmare, honestly. Whenever you can, just always have a motherboard that supports Wi-Fi built in because it's just better and easier. So for the SSD, we're going to be using one drive, which is going to be the OS and where the benchmarks are going to be on. It's not going to be that massive, but this is going to be a Gen 4 drive, Cardia Z440, about 4.5 gigabytes per second read and write speed. Gen 4, very good SSD, plenty of speed here to keep this system on the good wraps. The really good thing about this motherboard when I'm using the GPUs here is that this button, I can just pull the GPUs out by pressing this button, which right now I'm going to have to use the screwdriver to do that, which is absolute nightmare. This is much better. For the RAM, we're using Kingston Fury Renegade RGB DDR4, and this is 64 gigabytes because as a creator, all the creator benchmarks that we're doing, if we're using less, it's gonna actually be a bottleneck in the system, but this is not. So this is 3600 mega transfers per second and CL18. Not the fastest, but honestly, not gonna make a ton of difference for us here as creators. Now for the cooler, we're gonna be using Arctic Liquid Freezer 2 360mm AIO. Very affordable, very quiet, very good in every single way you can think of. It's one of the best coolers that you can really get for when we're talking about AIOs. This way we shouldn't have any bottlenecks in our CPU cooling. They need to figure out a better way how to attach these little standoffs around these massive heatsinks of the motherboard VRMs, because look at that. Like, you can't put your fingers in there. I've got very small hands and I'm struggling. If you've got big fingers, then it's going to be very hard. You might need to use some kind of tool. Here's the power supply which we're going to be using for that. 1200 watts of pure power from Be Quiet, premium power supply, 80 plus platinum, very quiet, very high quality, so we know that we're going to get good juice for the GPU, and it's enough power to keep everything well powered. Now, interestingly, this power supply has slightly different cables for the PCIe connectors. So they're 1, 2, 3, 4, 5, 6, so 12 pin there, but not the one that we see on the NVIDIA, connector. Basically, there's 3 of them, but there's 2 8 pins coming out of them. So like to save kind of connector space on the actual power supply, there's 3 connectors, but we're getting 6 8-pin PCIe connectors out of them over there. But I think I'm gonna connect only 2 of them because right now I don't know any GPU that pulls or uses more than 4 of these. So later on we can attach that one when we need to, but for now that's gonna be plenty of power. Let's take this beautiful case out. Why this case? Well, I saw this case online and then I asked if AZZA would like to send this over just because it's very interesting. I haven't seen anything like this before. It's got a mesh front panel, side panel, and then top panel. Only the left or back side of the panel here is actually not see-through. Look at that. It's all just mesh, which means that I can have the side panel on and pretty much know that my GPU is not going to be like air restricted. Top is just magnetic cover. Actually, we don't need to take the top panel off because there's already 3 120mm fans installed in the front and then 1 in the back. So when we're looking at the cables here, we've got 2 USB type A front panel connectors here. No front panel type C connector, but all the fan cables here have been connected together into this interesting kind of mesh type of thing. So there's 3 cables that come out from every single fan, right? One of them is the usual 5-volt ARGB header that you connect to the motherboard. But the thing is, if you look in the back here, there's actually 2 connectors or 2 cables that come out from there. Usually there's 3 because I believe that it doesn't get the actual 5 volt from the motherboard, but it gets it from the SATA cable that's also connected here. If we look at the other cable that comes out from here, is just this little 2-pin header, which is random, and then you've got the actual PWM connector that connects to the motherboard, for your fan speeds and so on. Here's some motherboard screws and stuff. And another thing we're going to be doing is taking off the hard drive bay that's included there, because that's just going to take extra space that we are not going to be using, so that comes off. So let's put the motherboard inside the case. The interesting thing here is that there's no nubbins on the motherboard standoffs, which is slightly cheap of the case. Usually you would have a nubbin and then it's much easier to actually install the motherboard, but right now it's sliding around before we actually screw it in. There's no big instructions, just like download the manual through here. 1 bag of screws. Okay, I'm starting to realize that the case is actually rather cheap, just because I just realized back PCIe covers, slot covers, are actually built in, or you have to break them out, so it's not like one of those screw-in ones. Whenever you want to push the back piece out, you'll have to break them like that to get it out, and you can't put them back. They do include like 2 covers with them, which I guess is actually fine for most cases, because if you put a GPU in there, your GPU will come in there, and then you have these 2 covers, let's say for the bottom ones, to have extra 2 or something, slots like that. But it's cheap, what I'm saying. It's not ideal, it's cheap. So before I'll put the CPU cooler in there, it's very important to put actually the CPU power cables, attach them to the motherboard first, because probably not gonna have any space to do it afterwards. Here's another good thing about this power supply. As you can see, we've got the 8-pin connector, and the one that goes to the PSU is a 10-pin connector, just for extra 2 pins that are just empty inside, so you can't make a actual fault of plugging them in wrong way or forcing them in wrong way. No way you can do that, which is very, very good and thoughtful of Be Quiet. Okay, the plan is to mount this on the top. Okay, so here's a little thing. In order to put the AIO in there, because that fits pretty much exactly there, I have to take the back fan actually off, because the back fan won't fit anymore. And I'm gonna go a little bit of an unconventional kind of tubing for this, and I'm gonna put the tubes on the right side rather than in the front, then the tubes will be going in there like that. The reason for that is that I'd rather lose the back exhaust fan than the intake fans from the front, because the one intake fan from the front and there, that would just get nice, you know, cool air to the GPU and inside to the CPU and everything as well. So I can put that in there, which is much, much better than losing the one outtake there, because it has pretty good exhaust anyway. I've got 3 exhausts in the top over there, basically doing exhaust, all of it inside the case anyway. I think this is a better option than the other way around. Alrighty, time to put the cooler on, but before that, let's clean the CPU. A drop of that. So we're just brushing all the fibers off, but it's now completely clean. And also recently I've started to apply thermal paste slightly differently than usual. Basically I'm starting to love these little spatulas that you're gonna get, and here's the thermal paste. I'm using the Noctua NTH1 thermal paste. What I'm gonna do is I'm gonna put a little stripe on one side of the CPU, just like that. And then now use the spatula to spread it out around the CPU. Now, as you can see, this way we can get a properly evened out thermal paste application all around the CPU, and we know that it's spread everywhere. It doesn't matter how I'm gonna push the heatsink down, it's still gonna go all around it, and it covers all of the high IHS. Sometimes when I'm doing dots and stuff, I'm putting either way too much thermal paste, which actually isn't bad, but just cleaning up afterwards, there's gonna be loads of thermal paste all over the place, whereas you don't actually need it. Now it's all over the place, and I can just easily mount the CPU cooler on top of it. Now, the very interesting thing is that inside the PC case, there was actually these long screws, and I was thinking, why would they give me these screws? Now I understand. What you can do is actually put the fans on the bottom here as well. There's 2 fans on the bottom that you can have for extra like intake from the bottom onto your GPU. Just install them in there just like that. It's a very good option, but I'm not gonna do that because it's just too much. We need to give the GPU something to do as well, not just cool everything down. But if you want to do it in your case, I think you can completely do it. In my case, it's just I want the GPU cooler to actually see how well the cooler is as well, to have a kind of a little bit of a, you know, some kind of airflow there. Otherwise, we're not testing the GPU cooler. Okay, so there's a bit of a thing with these fans and all these cables, because what they've done here is absolutely ridiculous. Well, basically they have chained all of these fans together, and you need to have all of these fans in order to get the RGB working, because the front 3 fans are almost like slaves to the one in the back fan, because the back fan has more ports that come out than the other ones. The back fan is the only one that has the normal motherboard PWM connector, as you can see here. And what you're supposed to do is daisy chain all of these together into this one through like these proprietary connectors, which are not like standard connectors. And then from the back cable, you'll have, I don't know what you're gonna do with this even. Like there's a 2-pin that comes here, but where is that 2-pin supposed to go? Because there's too much cable faff going around, I might just change the fans to something different in the front here. There we go. So I'm gonna use these Arctic fans. So they're the same fans that are on the top, but basically these are much more simpler in terms of just wiring, and I don't need RGB for this test bench. The RGB is just a waste. I'd say if you use the case, just, you know, buy the case and then you just want to use these cables, you can get them to work. There's a heck of a lot of cables, more than you need really, just because of cheap engineering, I think. So in our case, we are taking these cables off. I've caved in, and we're gonna do the original fans, use the original fans, just because I can show you what the RGB will look like, and I'll figure out the wiring. So that's what we're gonna be doing now. Okay, one more thing. There is like this 2-pin that comes out from the master fan, which is in the back fan that was usually there. So basically what you should be doing with this is, or can do, is use this and plug it into the reset switch header that comes from the front panel buttons there. And basically when you put the reset button inside here, right now I have actually put it onto the motherboard, but what you could do then is this reset button can also change the like LED cycles or different LED modes, but we're going to be controlling that from the motherboard, so I'm not bothered about that. I'm not going to do cable management on this case because the whole point of this is if something's not working or I need to change something quickly, I can just do it basically. All we do is hide it all. Very nice thumb screws actually. Let's see if this GPU is going to fit inside there, because that's quite a big one. I don't have the Strix, and I'm not sure if Strix is actually bigger. Maybe the ASUS Strix is a bit bigger, but this is quite big as well here. These PCA covers are absolute nightmare, and I don't think any case should have these, especially if you've got motherboard already installed, because when you break it off, one side is actually rubbing just on the SMDs of the motherboard. I wouldn't recommend that. This back bracket cover is nice because it should hold like the GPUs intact, but I'm just gonna remove it because most of the time for me GPUs come in and out, and I just need to have access to these screws as quickly as possible. In my case, obviously this panel will be off, but let's say if you wanted to put a panel on here, look how much pressure there's going to be on these cables. By the way, that should be completely fine. If you've seen Gamers Nexus's last video about the actual, NVIDIA headers, then the main point is basically if it's not properly plugged in, all the bending in that should be completely fine. So this would bend against your panel, and then I guess this would bend somehow like that, just to show you that it is possible. Okay. That's on. Let's turn it on. There we go. Checking VGA. You see the white light? There we go. Okay, here we are. As you can see, we are in Windows. I've installed all the drivers, done everything, download the programs, things like that. And one of the first things that I want to do is check if the chip is running cool enough. What we're going to use for that is Cinebench R23. I'm going to run this test and let's start checking the temperatures. I've actually done it off camera before, but I want to show you something that I've noticed on this chip. So you can see all the P cores are going 4.9 and all the E cores are going to 3.7 gigahertz. If you look at the first test here, core temperatures seem fine. We're pulling about 225 watts from the socket, something like that. 93 maximum. Second run, 26,462. Good score. Okay, look at that. Almost 230 watts now. See, it peaked 231.5. Let's keep it running for a bit. Okay, this is very interesting. Previously, when I did it, and after about the second or third run, what happened is the core number 7, if we look at the core temperatures here, this number 7, as you can see, it's quite a hot one compared to the other ones. 94, the other 95. See, like it's a few degrees hotter than the other ones. CPU package, okay, we're 96, peaked 96. It was actually thermal throttling for some reason, and I thought, flipping egg, maybe something's wrong, but looks like the actual thermal paste application needs to like sit in a little bit as well. Yeah, because now I'm seeing much better temperatures than before. It was like thermal throttling up, I think P7 and P core, I can't remember now, P4 or P5. So it's interesting. My main point is I don't want the CPU throttling, because then we're getting or creating another bottleneck for our GPU test bench. What I need the CPU to do is run 100% all the time and not get bottlenecked like at all. 98, look at that P core now. It pushed to 97, as you can see there. Now we have gone like about 6 minutes, 100% utilization, which you don't really see in the GPU test bench. I think once we've completed the 10-minute mark, then that's it. 98. Okay, we have thermal throttled, as you can see. Core thermal throttling, Let's have a look, which core was it? Yeah, P7. Can you see? That P Core 7, that is like getting a bit toastier than the other ones. What I have here is the Intel's Extreme Tuning Utility, XTU for short. As creators, I don't recommend you doing this. Generally, I think it's best to just throw the CPU in and then kind of leave it just because of the stability. We don't want to do that. Look at that. That's the interesting thing. Look at the P Core 7 is 93 and P Core 1 is 81. There's 12 degrees difference between the P cores. Look, it's running 79 and then P Core 7 and 93, 94. But interestingly, look, it looks like the thermal paste has set in. Because look at that. We did peak like 97 degrees and we started thermal throttling on the Core 7. But right now, look at that. All cores, 228 watts, 83, no problem. Look at that. Just looking at a single run here. Boosting to 80, 87, 88, 225. I'm seeing that the thermal paste is actually setting in. I've done this test now like probably 20 minutes off camera or just cutting off a little bit, and 225 watts. So it's getting better temperatures, which means less voltage leak, and we're pulling less. See, like when it gets hotter, the kind of transistors and things, how the cores work, we're getting a bit of a voltage leak, which means we're pulling more power through to sustain the same clock speeds. So that's why you do want to actually keep the CPU as cool as possible. I'm quite happy with this. I think this is good enough for the GPU test bench. Let's see the GPU here as well. NVIDIA. This is interesting. When I used the previous test bench on the B660 motherboard, I could see only maybe 405 watts being pulled. But this one here now is boosting to 450, but then settling around 420 watts or something like that. Let me see if there is 1080p. So in here we can see we're pulling 415 watts. What does hardware monitor tell me? 415. There was a boost of 450, but then 415 is what we're seeing here. 493, okay, TDP. We're not like hitting the TDP actually. 418 watts. CPU temperature is fine. GPU temperature, pretty good as well. Looks like our GPU is fine though. Ooh, it's hot. Back panel's very hot. This is completely fine. The only annoying thing that I have found about this is I am not sure that these fans are even PWM actually controllable. Because when I went to the BIOS and I've got them plugged in, ow, there's nothing there, chassis fan 4, 5. For some reason the case fans there, even though I have connected them in to that slot in there, they're not doing anything, which is really, really annoying. And the annoying thing is the fans aren't RGB controllable either, even though I've got it connected to the motherboard. So the fans are a bit of a nightmare, to be honest. That RGB is not working either. Let me double check the connections. Yeah, the fans are plugged in right. It's just random. The RGB doesn't quite work, and the fan speeds don't respond to it either, so it's a bit random. But other than that, this is the new GPU test bench. The front panel looks quite cool. I'm slightly disappointed actually about the case, because I was hoping that the case would be a bit better quality. The front is cool. This AZZA should light up, but for some reason it totally isn't. I know AZZA does cool things, and this does look quite cool, but actually the case is quite cheap. I don't know. Let me know what you think in the comment section below. If you have any other questions, I'll meet you down there. Thanks guys for watching, and I'll see you soon. Bye bye.